Hello, everyone. Good evening. Good morning. Actually, you guys are going to be watching this in the morning. I'm making this video for you in the evening. So good morning, everyone. You will see that you have a factoring worksheet. It looks like this. This is what you guys are completing today. So I wanted to take a moment to take a look at each one of these problems and give you some tools, some tips on doing them. First off, I want to go a little bit of a review over exponents. So let's talk about exponents for a little bit. With exponents, those are the numbers, those tiny little numbers at the top. For example, we have y, and then we go to the third power. That third power, that 3 is our exponent. When we are dealing with exponents, say you have to divide an exponent. So say I said y cubed divided by, this is just a little side note, a y squared. What I do with the exponents is I subtract. Okay, I'm going to say y cubed minus, so I'm going to say y to the 3 minus 2, and I would get y to the first power. Okay, y to the first power, and that would be the answer if I had y cubed divided by y squared. Okay, now why am I talking about exponents and dividing exponents? When we divide exponents, we're actually subtracting. So for example, let's do another one. If I have x to the third power and I divide it by x, well, there's no exponent on the x, but there's an invisible number 1. Whenever you see a variable and there's no number there, there is an exponent of 1. So I would subtract the exponents if I'm dividing. So x cubed divided by x to the first power would actually be x to the 3 minus 1. And then we know that 3 minus 1 is 2, so that would be x squared. So that means x cubed divided by x to the first power, or x, is x squared. Okay? Why am I reviewing this for exponents? Because when we're talking about factoring, you're going to be factoring out. And if you don't remember, factoring out is actually, when you're factoring out a number, you're actually dividing. You're actually dividing. So what we're going to do here, what you're going to see here, let's look at number 1. I'm giving you guys tips on each one of these problems. By the way, you're doing numbers. You're doing problems. You're doing problems 1 to 8. You're not doing the entire worksheet. Pay attention. 1 to 8 and 15 to 20. Okay, so let's take a look at number 1. I'm giving you tips for each problem so you can do well on this. Number 1 is greatest common factor. That is a factoring tip that you're going to use when you are doing number 1, greatest common factor. Okay, so what I'm going to do is I'm going to say, what does y cubed and 9y squared have in common? Well, first let's look at the coefficients. Coefficients is a fancy word for saying the numbers in front of the variables to the left of it. So with this y cubed, the coefficient here, even though we don't see it, is a 1. And then the coefficient on the 9y squared is the 9. Well, if I look at the coefficients, 1 and 9 don't have anything in common, so you would be like, oh, there's nothing in common. However, let's look at the variables, y cubed and y squared. They both have y in common, but not just one y. They actually have 2 y's in common, right? If I was to write this out, this is y times y times y. That's y 3 times. And if I was to write this one out, this would be 9 times y times y. Okay, so you could actually break it down. Let me put a plus in between here. So if I was to expand this problem, that's what I would see. 9 times y times y, right? So they have, how many y's do they actually have in common? They have 2 y's in common. They have these 2 y's and these 2 y's in common. So when I factor it out for the greatest common factor, I'm actually going to factor out y squared. That 2 lets me know there are 2 y's. I'm going to put parentheses, and I'm going to put what's left after I factor it out inside the parentheses. If I factor out the two y's here, I'm left with one y, or y cubed divided by y squared is y. That's what we were doing up here. That's why I introduced you guys to that. Y cubed divided by y squared is y. Plus, well, if I factor out the two y's, y squared divided by y squared would be 1, right? Y squared divided by y squared is kind of like just saying 4 divided by 4. Y squared divided by y squared is going to be 1. So we're left with 1 times the 9 because we didn't do anything with the 9. So we would put that right there, and that would be 9. And that would be our answer for number 1, greatest common factor. Okay, let's take a look at number 2. And you should be writing this down because this is your homework. So I actually just gave you an answer. Number 2 is the same concept of greatest common factor. Look at the coefficients first, 5 and 15. What do they have in common? Write it down. Next, you're going to look at the variables. Look at the x squared and the x cubed. How many x's do they have in common? Write that down. And then you're going to look at the y cubed and the y squared. How many y's do they have in common? Write that down. So whatever that greatest common factor is, you write it on the outside. Then you open the parentheses and you write what's remaining after you factor out what they have in common in the parentheses. Okay? Let's take a look at number 3. This one is a little tricky because there are 4 terms. This is a factor by grouping problem. So the first 2 is greatest common factor. This is a factor by grouping problem. Okay? Why is it called factor by grouping? Because we're going to group the first 2 terms together, meaning I'm going to put parentheses around the first 2 terms, and then I'm going to put parentheses around the last 2 terms. And I'm going to find the greatest common factor between the first 2 terms. Then I'm going to find the greatest common factor between the last 2 terms. Okay? And actually, because I know you guys didn't work so much with factor by grouping, you could stop right there. And then when we get together, I'm going to tell you what the next step is. But what I want you to do is identify the greatest common factor, identify the greatest, I'm going to put GCF, the greatest common factor between the first 2 terms and the last 2 terms. And we're going to stop right there because when we get together, we're going to talk about what that means. Okay, so what we do when we do factor by grouping, but I want you to get comfortable with the greatest common factor between numbers and variables. Okay, so that's number 3. Number 4, this is a difference of squares. I love difference of squares. I hope you do too. They're by far, to me, I love them. They're pretty basic, right? If you remember difference of squares, let me go ahead and type that. And you can see it in your handouts for notes, difference of squares. If you remember the difference of squares, you have, if you have a squared minus, that's why it's called difference, b squared, when you factor it out, you take the square root of it, and it'll just be a plus b times a minus b, right? So if you have p squared, then the square root of p, okay, let me go back up here. So if you have p squared, then the square root of p squared would be p. If you have 36, what's the square root of 36? 6. So then you put it into this format, right? Number 5 is the same thing, difference of squares. In this case, the x is just coming second, so don't let that throw you off. Okay, so number 5 is also difference of squares. Number 6 is a difference of squares, but you have to do greatest common factor first. Okay, so it's like a combination. You know, we like to make things complicated as mathematicians. So what do they both have in common? What does 4a cubed minus 49a, what do they both have in common? Well, they don't, I mean, 4 and 49, even though that's a 4 and a 49, they don't have any factors in common. You know, I can't say 49 divided by 4 and get a whole number. So that's not it. But they do have a variable in common. They have 1a in common. So if I factor out the 1a, I put parentheses here. What's left is I get 4a squared when I factor out a from 4a cubed, meaning I divided 4a cubed by a and I get 4a squared, minus, and then if I divide negative 49, if I divide 49 a divided by a, I get 49. So now I have 4a squared minus 49. Those are both perfect squares, and that's where you do the difference of squares. So I'm going to stop right there, but you don't. You need to do the difference of squares on what's inside the parentheses. Okay? Believe it or not, number 7 is also a difference of squares. Okay? The square root of a plus b squared would just be a plus b, and the square root of 100 would be 10. So don't let the fact that it's in parentheses, because it's a 2 right here, that makes it a perfect square. So you are also using difference of squares with that one, okay? Number 8 is also a difference of squares, okay? So if I was to do this, the difference of squares, the square root of 9 would be 3 minus, and then the square root of x minus 2, quantity squared, would just be x, I mean not x minus 2, x minus y, would just be x minus y. Okay? And I would put that in brackets or parentheses, and then do the other set of parentheses, and then I would say 3 plus, I'm actually giving you guys the answer for number 8. And then this would be x minus y as well still. Okay? And that's how you would do number 8. So number 7 is just like number 8. I just decided to do number 8 just so you can see how that works out. We're skipping 9 through 14. And what I'm going to do is I'm actually going to create another video for the next set, 15 to 20, just so you guys could take a break right now and do these greatest common factors and difference of squares. So right now you focus on greatest common factor and difference of squares.